All right, this lesson is on trigonometric functions of any angle. So below is 4 different examples of angles that fall in the 4 quadrants. So example A is quadrant 1, and this acute angle has a point X and Y, and we create a right triangle. And here is my angle theta. This is my x distance and my y distance with my point, and then my radius. Quadrant 2, here is the angle theta, and then we have our right triangle drop down with our point. This is our x, y, and r. We will need to use a reference angle that I'm highlighting here in the red. The third example is in quadrant 3. Here is your angle, and then you create your right triangle. You have your x distance, your y distance, and your r, and here's your point xy. You'll again have a reference angle highlighted in the red, and we'll talk more about that. And then the last example, quadrant 4. Here is your angle, finishing off on your terminal side. You create a right triangle. You have your y, your x, and your r, and then your point. So these figures show angles in standard position that are not acute. We can extend our definitions of the 6 trig functions, the sine, cosine, and tangent, the cosecant, secant, and cotangent. And we're going to work with the terminal side on the x-axis or the y-axis, and that point xy may not be on the terminal side of the angle or the origin. So here is an important yellow box. It says we have an acute angle in standard position. So we have our ordered pair, x and y, on the terminal side where it stops. To find that radius, we're going to use the Pythagorean theorem. So x squared plus y squared equals r squared. If we solve that for r, we would square root both sides. So that's how you get this equation here. So these are the 6 trig functions. So to find the sine of that angle, you would take y over x. To find the cosine, we would take x over r. To find the tangent, we would take y over x. And then that x cannot be 0, makes it undefined. And then these 3 are your reciprocals to the big 3. And then these on the left are your big 3. So here's an example. We have a point, -3, -5, on the terminal side. So here is our coordinate plane. Here's the x-axis and the y-axis. We have a point sitting down here at -3, -5. So this is our x value and our y value. Here would be our angle, standard position, finishing off. And this is our angle theta. Well, this is not an acute angle, not less than 90 degrees. So we're going to have to use the ratios on the previous slide. So we're going to go ahead and create a right triangle. So we're going to create it going up to the horizontal line, across, and then down. So this is our x distance, which is -3. Our y distance is right there, -5. And then we have our radius. This is not the unit circle, so the radius is not 1. So we need to use that equation, x squared plus y squared equals r squared. So we're going to solve that for r by undoing it. So we're left with that as our r. So now we're going to sub in. So we're going to substitute the x and y into that equation. So the x was -3, so it's going to be -3 all squared. The y was -5, so -5 all squared. Simplify, 9 plus 25 is the square root of 34. So I'm going to go ahead and write that over here. We do want you to leave it in exact form. So now we found the x, the y, and the r. Now we're ready to use our trig ratios. So from the previous slide, we're going to use these big three first, and then we'll do the inverses. So the sign is y over r, -5 over 34 square root. We do need to rationalize that. So we're going to get -5 square roots of 34 over 34. Then cosine. Cosine is x over r. So x is -3. Radius of square root of 34. And then rationalize it. -3 square roots of 34 over 34. Tangent. Y over x. The y is -5. The x is -3. Simplify that to a positive 5/3. Now I'm going to do the inverses. So these are just the inverses of your big three. So we're going to get the square root of 34 over 5 with a negative. We're inversing the cosine, negative square root of 34 over 3. And then inverse the tangent, 3/5. Here's another example. We give you the angle 90 degrees. Or pi over 2. I want you to find the sine and the tangent at the following 4 quadrilateral angles. So we're going to work with 90 degrees. So remember this ordered pair up here. It's over 0, up 1. This is your x and your y. So for 90 degrees, it's going to be y over r. Well, this is our y. And then our radius is also 1. So 1 over 1 is 1. The tangent of 90 degrees, so the tangent is y over x. So the y is 1 and the x is 0, which makes that undefined.